With chronic leukemia, leuc refers to white blood cells, and emia refers to the blood. So in chronic leukemia, there are lots of partially developed white blood cells in the blood over a long period of time. These partially developed white blood cells interfere with the development and function of healthy white blood cells, platelets, and red blood cells. Now, every blood cell starts its life in the bone marrow as a hematopoietic stem cell. Hematopoietic stem cells are pluripotent, meaning that they can give rise to both myeloid or lymphoid blood cells. If a hematopoietic stem cell develops into a myeloid cell, it'll mature into an erythrocyte, or a red blood cell, a thrombocyte, or a platelet, or a leukocyte, meaning a white blood cell like a monocyte or granulocyte. Granulocytes are cells with tiny granules inside them, and they include neutrophils, basophils, and eosinophils. If a hematopoietic stem cell develops into a lymphoid cell, on the other hand, it'll mature into some other kind of leukocyte, like a T cell, a B cell, or a natural killer cell, which are referred to as lymphocytes. Once the various blood cells form, they leave the bone marrow and travel around in the blood or settle down in tissues and organs like the lymph nodes and spleen. A chromosomal abnormality in hematopoietic stem cells that are destined to become leukocytes is the most common cause of chronic leukemia. Some examples of abnormalities include a chromosomal deletion, where a part of a chromosome is missing, a trisomy, where there's one extra chromosome, and a translocation, where two chromosomes break and swap parts with each other. Now, there are two types of chronic leukemia. The first is chronic myeloid leukemia, or CML, which is caused by a particular chromosomal translocation that affects granulocytes. The second is chronic lymphocytic leukemia, or CLL, which is caused by a variety of chromosomal mutations that affect lymphocytes, in particular B cells. Both CML and CLL cause cells to mature only partially, and that's a key distinction from acute leukemias, where the cells don't mature at all. As a result, these abnormal, premature leukocytes don't work effectively, which weakens the immune system. In addition, the chromosomal changes alter the cell's normal cell cycle. As a result, in CML, the cells start to divide way too quickly, and in CLL, the cells don't die when they should. And in both situations, we're left with way too many of these premature cells. So over time, premature leukocytes accumulate in the bone marrow, until eventually they spill out into the blood. Now, some of these guys settle down in organs and tissues across the body, but others keep circulating in the blood. With a bunch of extra cells in the blood, all the healthy cells get crowded out, and it's tough for them to survive with the extra competition for nutrients. This causes cytopenias, or a reduction in the number of healthy blood cells, like anemia, which is a reduction of healthy red blood cells, thrombocytopenia, a reduction of healthy platelets, and leukopenia, or a reduction in healthy leukocytes. In chronic myeloid leukemia, the most common cause is a chromosome translocation, which results in a Philadelphia chromosome. And that's where a portion of chromosome 9's long arm switches with a portion of chromosome 22's long arm. And we write that as TN22. T because it's a translocation, and 9 and 22 because those are the chromosomes that switch genetic information. This results in a modified chromosome 9 and a modified chromosome 22. And it's the chromosome 22 that's called the Philadelphia chromosome. So in the Philadelphia chromosome, a chromosome 22 gene, which is the BCR gene, ends up sitting right next to a chromosome 9 gene, the ABL gene. When they're combined, it forms a fusion gene called BCR-ABL, which codes for a protein also called BCR-ABL. And that protein activates enzymes called tyrosine kinases. Now, some of these tyrosine kinases are like on-off switches for various cellular functions, including cell division. So when the BCR-ABL fusion protein turns on these tyrosine kinases, it forces myeloid cells to keep dividing quicker than they should, which causes a buildup of premature leukocytes in the bone marrow that eventually spill into the blood. The premature leukocytes then move to the liver and spleen, causing swelling of those organs or hepatosplenomegaly. And because these CML cells divide quicker than they should, there's a high chance that further genetic mutations can happen. And if that happens, CML might progress and accelerate into a more serious acute leukemia, which is called a blast crisis, because the totally immature cells of acute leukemias are referred to as blasts. A lot of cases of these blast crises include the formation of a trisomy on chromosome number 8, or the doubling of the Philadelphia chromosome. In chronic lymphocytic leukemia, the most likely cause is also a mutation in the cell's chromosomes. We just don't know which particular mutation, or mutations. Whatever the case, the result is that B cells start to interfere with the pathways of B cell receptors, which should only be signaled during infection to activate a few specific tyrosine kinases. Interference with Bruton's tyrosine kinase, for example, is probably what stops CLL cells from maturing fully. And it's similar interference with other tyrosine kinases that allows them to die slower than they divide, which is why they build up. These premature cells always express particular proteins on their surfaces, including CD5, CD19, and CD23. The CD part stands for cluster of differentiation, because these are common surface proteins which can be used to differentiate between the lymphocytes. And despite CLL cells being B lymphocytes, they express the CD5 protein, which is a lot more common in T lymphocytes. Anyway, these premature leukocytes build up in the bone marrow and eventually spill into the blood, like in CML. Some of these cells then move to the lymphatic system, and although this does include the spleen, the lymph nodes are typically prioritized. This causes swelling of the lymph nodes, or lymphadenopathy. Then eventually, B cells in these nodes will accumulate into distinct masses, or lymphomas, which is why mature CLL is sometimes called small lymphocytic lymphoma. Further progression might take the form of a Richter transformation, where those small, pretty harmless lymphomas collect into sizable masses that damage the body. And because B cells normally work in the immune system, the reduced or adverse functioning of CLL cells might result in autoimmune hemolytic anemia, where the cells attack the body's own red blood cells and kill them off. Or hypogammaglobulinemia, where the cells don't produce enough gamma globulins. Symptoms of both CML and CLL include fatigue because of the anemia, easier bleeding because of the thrombocytopenia, and more frequent infection because of the leukopenia. In CML, the hepatosplenomegaly often causes a feeling of abdominal fullness, while the lymphadenopathy of CLL often causes mild but localized pain in the lymph nodes. The diagnosis of CML and CLL usually starts with a blood smear, which shows a lot of premature leukocytes. In CML, there are an increased number of granulocytes and monocytes, and in CLL, there are often smudge cells on the blood smear, which are immature B cells that have broken during the smear. For a conclusive diagnosis, genetic testing can be done to look for the Philadelphia chromosome in CML and to look for chromosomal defects in CLL. Treatment for CML always includes biological therapy, with a tyrosine kinase inhibitor aimed at stopping cell division caused by the BCR-ABL protein. This is less effective for CLL though, since there's no specific target. Other options for both CML and CLL include chemotherapy, stem cell transplants, or bone marrow transplants. Alright, as a quick recap. Chronic leukemia is a cancer of the leukocytes that includes both chronic myeloid leukemia, or CML, and chronic lymphocytic leukemia, or CLL. In CML, chromosomal translocation results in a Philadelphia chromosome, which codes for a protein called BCR-ABL. As a result, myeloid leukocytes like granulocytes and monocytes stop maturing and reproduce too quickly. These build up in the liver and spleen and cause hepatosplenomegaly. In CLL, a variety of chromosomal abnormalities interfere with the pathways of B cell receptors. As a result, lymphoid leukocytes like B cells or B lymphocytes stop maturing and die too slowly. These build up mainly in the lymph nodes, causing lymphadenopathy. Both types cause a loss of normal blood cells, resulting in things like anemia, thrombocytopenia, and leukopenia.
Hey guys, Vince here. So, chronic leukemia. Premature blood cells run amok in the body. It's bad news, right? So, I hope that today's video was useful to you. Today's script was written by Thomas Bush. It was edited by Kyle Slynn and Rishi Desai. For the video, I created the illustrations, Tanner Marshall performed the voiceover, and Evan DeBevick McKinney did the video editing. As always, if you'd like to support the creation of more of these kinds of videos, check us out at osmosis.org. There you'll find all sorts of great tools that'll help you learn medicine. This includes all of our unreleased videos, which Tanner just completed an 8-part series on ECG. It looks fantastic. I encourage you to check it out. You can do so for free. We also have tens of thousands of flashcards and quiz questions, study organizers, just a whole suite of tools in one place that'll help you learn medicine. Anyway, thanks a lot for watching our video. I'll see you next time. Bye.